Good morning, everybody, and welcome at the PASC22 conference in Basel. We have the pleasure to have with us the keynote speaker that opened the PASC conference, Pier Luigi Vidale, Professor of Climate System Science at Reading University, or University of Reading. Welcome, Pier Luigi, and thank you very much for your time. So you gave a very inspiring talk, and my first question, you have been saying repeatedly during your talk that our models are wrong and that we need to improve the uncertainty to have a better representation of the reality. But what exactly do you mean that our models are wrong? Are wrong in absolute terms? Are wrong in just because they are limited? Would you try to explain to us a little bit, as not expert, a bit more?
Well, so the climate system is a very complex system. It spans a huge range of scales. So the models are good at representing some of these scales. So the planetary scale over maybe long time periods. What people care about is, last night we had a very big storm here in Basel. They want to know, what does it mean for me? What will happen to me in my lifetime and to the things I care about? It could be my home, it could be my job, it could be the people I'm friends with, maybe on the other side of the planet. So depending on the scale, depending on the lifetime and the phenomenon, the models have different skills. So one of the things I was showing is, if we are predicting global temperatures into the future and we're looking at the whole planet over very long time scales, the natural variability of the system, so what the Earth would do even if mankind was not around, is rather small. And what we call the scenario uncertainty, so what we are doing to the planet, is very important. While the errors in the models are there, because again we do not represent all the scales, we cannot go down to the individual bacteria in the soil or to every leaf in every tree. Those errors at the global scale are not very important. Now, if we move to a particular region or a particular locality, and we are trying to predict things over all of these time scales, then yes, the models have trouble because they cannot represent all the scales and all the scale interactions. But even for big things like big cyclones, some of the models are unable to represent the cyclones in the full range of intensities. So
okay, but then my next question to you is, what do we need to have models that they are able to represent the reality?
So in part, one of the answers is model resolution, because as we increase the resolution, we extend the range of scales we do represent explicitly, instead of using what we call parameterizations, which are sort of empirical substitutes for physics. So that's one aspect. The resolution does help in some of this. But also what we need is several realizations of that event or that chain of processes, to understand to what extent it is connected to things like climate change, anthropogenic climate change, but also to understand, well, we had Katrina. Katrina hit in a particular way and caused a certain flooding in New Orleans. What if Katrina had been just a little bit to the west and a little bit to the east? What would the consequences have been? If it just been a few kilometers away, maybe the levees would have held and then the impact would have been less.
So from what you're saying, I have to understand that actually climate does need a lot of computational resources to achieve exactly what you are telling us. So we do need more compute power.
Absolutely, we need a lot of compute power. And
but what about the data then? How are you dealing with the data?
So I was telling the little story about the ETH manager telling me off for writing too much data. So I'm writing a lot more data nowadays. In fact, in Primavera we output 4 petabytes of data, and I think because it's relatively recent, we've been pretty good. We've already looked, analyzed and published about 10% of those data, which compared to the community is a pretty good number. We will eventually exploit the whole 4 petabytes of data, but the next project, ERIE, will do even more. So what we need to do is, first of all, understand what's really important. So, for instance, big cyclones, extremes of precipitation, extremes of wind and all that is really important. So we want to output a very high frequency. And other things that are more connected to the Earth system, more specialized and not so directly involved with impacts. Maybe we can save at a lower frequency. But what people are developing are new methods to store data in ways that are aware of the process. So they will only store the information where it's needed. And there are also some new data compression techniques and all that. But we're moving towards, in reality, the so-called diagnostics online. So we find what we want while we're running the model, and we do not store, because that is really a huge energy loss and it's very costly.
So also you have to consider the impact on climate of your own research. I would like to ask one last question. I read recently that actually Europe, there are about 300 tornadoes in Europe per year. It's just that they are not really of high intensity, and so we usually we don't mind them. So is it really true that these tornadoes is not really a US phenomenon, and also Europe is affected by this? I was reading about this because of this Germany event last month.
So you're now asking me something way outside my... So you think climate covers everything?
No, but you talked about typhoon, cyclones, extreme storms. Tornadoes are also kind of...
Typhoons are huge beasts and tornadoes are very small. But I lived in Colorado, so I was sometimes seeing tornadoes go by far away on the horizon. So it is true the US has a lot more tradition of studying tornadoes, and they seem to have a lot more impact, and definitely all the insurance companies I work with, their market for tornadoes is US, but they also do work in Germany. I am pretty sure that they lose more money there. Whether it is because of the intensity or because of the exposure remains to be seen. The other problem is what I can see across Europe is nomenclature is a big issue. A lot of people call these phenomena with very different names, so sometimes we're not aware it's the same phenomenon, we just call it something different. But there are people who are studying this, and they are developing models now in sort of the 100-meter range, and with very sophisticated approaches, mixing observations, especially radars, with models. And they're definitely coming up with a much better picture of what the spread of intensity is, what the locations of formation and all that. So there is going to be more and more systematic knowledge of these phenomena, and also whether or not they're changing, because it is possible that some of these phenomena are changing as our climate changes. Yeah. In the US, I know that some of these cyclogenesis and all that is connected to, so sometimes tornadoes are part of big organized mesoscale cyclones. Some of it is connected to the so-called dry line. There is a part of the US that is very moist and one that is very dry. On this dry line, you have intense convection developing. And Europe is going towards those conditions with climate change. Okay. So this could be, but it's not my field.
But,
really.
Sure, of course. Okay, Pier Luigi, the very last, we have already exceeded our time. So how important or how big is the human impact on the climate? Are we really the only one or the major responsible for this climate crisis?
Well, I think the last IPCC report once again gave you what the consensus understanding of this is. Yes, it is caused by humans. Now, what the weight of the impact is really depends on the phenomenon, on the region, on the time period and all that. And that's why we develop these global models, so that we can differentiate each type of weather phenomenon in terms of the chain of events crossing with the exposure for each region in very high detail. So the global picture is clear. There is no doubt. I mean, this is basic physics, but the regional picture is complicated and needs very sophisticated models for us to make decisions.
Okay, so we thank you very much again, Pier Luigi Vidale, and again for your amazing keynote, and we will be in touch.